Okay, good. Okay. I believe my screen is visible. Slides are visible, right?
Yes, sir.
Yeah, great. Thank you. So today we are going in depth technically in terms of what are the components we will be using in the smart grids, and also we will talk about the communication. There are certain protocols which, as an industry, which there we are going to utilize, right? So we will talk about those. Yeah. So yesterday we spoke about the six layers, right? So today it is all about so going in depth. So if you see, this is an kind of like the compressed version of six layers what we discussed yesterday, right? If you see, we have the field devices we spoke yesterday, right? So we have hold on, yeah, okay. So we have the field devices, right? If you see, we have the device itself, and also we have IEDs. So here we call it as in like these are all the IEDs, and also we will be having RTUs. So these are all very key important components in the smart system, where these are all called as the field devices or else device layer. So these complete the bottom layer is called as device layer, right? So IEDs, it is an intelligent electronic device, and RTU is a remote terminal units, right? So these are all called as the brain, where these two devices will collect all the data from these resources. It could be an the wind, it could be an solar, it could be in any kind of generation, right? So what this will do is it will collect all the information. Either it will process on field, either it can able to process in, if we have devices which is having the capability to process the data which we are fetching from these devices. Okay. And this is what, and coming to the so sensors. So we spoke yesterday, we will be having also the sensors, like we will be having, if you see here, like CTs, and also we will be having the PTs, right? So CTs is all about the current transformers to measure the current, and the PTs is all about the voltages, right? Hold on. Okay. Okay. Yeah. So this is what we are having, and also we are having the sensors, we are having the IEDs, and we will be having the RTUs, and also obviously there will be in smart meters, right? So these are all the combined components what we will see in the device layer, or else we also call it as in the field layers, right? So this is where the data will be collected, and then the data will be moved up the layer. So if you see these arrows, right? Sorry. So if you see these arrows, you can observe it is all the data flow, right? So data always flows from the bottom layer to the top layer. So here from we already collected all the data using the IEDs, RTUs, and the smart meters. Then it will be flowing up the layer, and in the second layer we call it as in control layer, right? So if you see the control layer, this is we call it as in the brain, or else the compute layer, right? So what we are having here, the in the most of the cases, if you see any of the electrical systems, so it is all about the SCADA, right? So if you see the system, it is the SCADA. So SCADA is the nervous system or the brain, what we call. So it will help in automating complete control. So the data which we had collected in the device layer, it will be almost processed at the edge, right? The SCADA is called as the supervisory control and data acquisition, right? So we will be running an SCADA software, and also we will be storing the complete data which is acquired from the field devices in the databases. So these are all the databases, and these databases are processed. So this is the one way where we are having the operator who will be overlooking complete data inflow. So he will be monitoring what exactly the data needs to be stored, what exactly the data needs to be processed, and every control aspects, right? So what he will be doing is he will be monitoring in the real time. So basically he will be having, so we call it as an GUI, graphical user interface, or else HMI. So this is called as human machine interface. So by using these, what he will do is he will interact with the data. So which data? The data which we acquired from the field devices, right? So now, uh, so from this control layer, so we already have the data, and basically in the industrial term here, we clean the data, or else like there will be certain process where we are storing the data in a structured manner. So basically we might receive the data in unstructured format. So that unstructured format might be saved as in structured data here, and then the data is moved up to the cloud layer. For example, in the cloud layer, it could be, as I was giving an example yesterday, right? So this cloud layer could be an the AWS, and it could be an Azure. So it could be an AWS or Azure or GCP. So these three are the main important uh, service provider for the cloud as of now, and there are many. For example, we have an Oracle and so on, right? So these three are very important cloud providers for now. So let's say, so we already got the data from the control layers, right? Now there are very key components which we will be running inside the cloud. So for example, let's say there are certain algorithms what we have to run to have the analytics and forecasting. So there are like the control algorithms like supervised learning. That is the labeled data, for the labeled data. So these are all very important concepts. So probably you might get assignment based on these details what I will be talking today, right? So we will be having the supervisory learning. This is one of the algorithm what we will be using. So inside the supervisory learning, so we will be having regression. So this is one of the type. So this regression is used for the continuous value, right? So probably you might have heard about linear regression, the lasso. So these are all the algorithms. So what this algorithm will do is, so these algorithm will fetch these data which we already received from the field devices, and it will process. So it will process and give us the analytics. So this is one of the type, the supervisory learning. And also after regression we also have the classification type. In that we have the k nearest, or else we also have Other one is like decision tree, and also we have a support vector machine. So these are all the very important the algorithm, machine learning algorithm, what usually we use in the cloud layer, right? So these are all the supervised learning algorithm. So we have a other type also. I will be explaining, and don't worry, I will be giving the notes for these algorithms, so it will be very much helpful for you guys, right? Okay. So we spoke about the supervisory learning algorithm, right? And also there is second thing called as unsupervised learning. This is for unlabeled data. Correct. So in that we have the clustering, and also we have an dimension reduction. So this is one of the technique. So, and also the other one is we have is association rule. So the clustering. So inside the clustering, there are famous algorithm called the k-means, and in the dimensions like PCA, even the k-means. Also, we have hierarchical clustering and so on. If you see, if you go through any of the papers, right? So you will have the n number of machine learning algorithms what we actually implement in the real time, right? So this is what algorithms we are having, and this is the second one is like unsupervised learning, and we also have the third one, that is reinforcement learning. Okay, so this is kind of trial and error, I can say. So where we use the data. Let's say we already have this data which is non-structured and it is not trained, correct? So what we will be doing is we will use these data, and inside that there are couple of algorithms what we use. So the q means q learning, and the deep q networks, and so on. So this is one of the type. So basically we have three types. One is supervised learning, unsupervised learning, and the reinforcement learning. This is basically trial and error, where we will be training the machine learning model based on the data set what we got it, and then we will be using that model to predict the future outcomes, right? Now, so this is it was like initial stage of machine learning, these algorithms, but currently we have advanced models, so which is also called as deep learning, or you might be heard about Gen AI, correct? So Gen AI, and also we have deep learning. So these are all the latest models. So the problem with the older models, which I was telling, right, the supervisory, unsupervisory, and reinforcement learning. So there, we have to train the model. So basically, we need to give the data set, and we have to train the model such a way that it will learn the patterns, right? So after certain duration, after training that model, we'll use the model in the production, and in that, so it will uh, detect what exactly we need. But in the latest models, the generative AI and the deep learning, what this will do is it is the pre-trained models. We don't have to train those models. It is already trained with the millions of data sets. So basically, these generative AI models. So for example, we have Chat GPT, right? Chat GPT, Gemini, and there are so many GPTs, right? So it is a lot pre-trained models. So it is GPT is called as generative pre-trained models. So basically, we can able to just deploy these the models, And as I was telling, it is already pre-trained with the many millions of set, and this is based on the natural language processing. NLP is what we call it as. What is NLP? The natural language processing, where as an human we talk to other humans, right, in the plain English language. So in a similar way, we can able to interact with these GPTs, right? So how we are going to deploy it? So these GPTs can be deployed in one of the server here, and this data which we acquired from this, it will be stored in the database. And again, this the data what we are getting from the field devices is, it is real time and the continuous. So think about the volume of data now. So it will be in the terabytes, or else it could be in petabyte data also, right? So if you see the volume what we are getting the data, we have to store it. So one constraint when it comes to the on premises, so when I say on premises, it's all about you know uh, the data center or substations what we are having. We cannot store that kind of data within the on premises. So we can able to have, for example, 20 TB or 30 TB of storage here, right? So but this is not enough. So because the field devices every day, every minute, so these are generating the data for us. So what we have to do is, we just have to take the data from this control layer, and it has to be moved to the cloud, because in the cloud we can have infinite number of storage. Let's say uh, if the scaling, so we can able to do the horizontal scaling, right? So let's say, for example, this year we may consume 50 TB of data. So the next year it could be 100 TB of data. The so on. It will be growing. And also, as per the compliance, we cannot delete the historical data. It has to be archived. When I say it has to be archived, it should not be deleted. It has to be set for next 10 or 15 years as per the government compliance, right? So what is the best solution is, we have to store that in the cloud, where we will have the better the storage and the compliance, right? Now we have got the data here. So this is where we got the data. Now we already have our Gen AI, let's say uh, generative AI models here, and so these models will do is, so this will fetch the data from this database, and it will process based on our requirement, right? So now when we have these data processed, so what AI and ML model output will be? So output will give the these analytics, right? So these analytics. So basically, you will be hearing the term called ERP, correct? ERP software and Power BI, and there are a lot of business. The dashboards are there, right? So these dashboards will give us the insight about the complete system, this system, and the overview will be given in the dashboard. So, so let's say, for example, Bescom, right? So if they want to see what is the billing for this month, or else what is the power consumption for this month, or else like he want to see the uh, customer base, correct? He can able to just log into the specific dashboard, and he can able to see complete details. And also this is a dynamic dashboard, right? Dynamic, when I say dynamic, it is on the real time, and this data will be refreshed at a regular interval of time, right? And therefore anybody at any given of time, when they log into the system, they can able to see the real-time data, not the static data. So when I say the static data, it is all the already, the data which is already present. It kind of historical data, I can say, right? So it is all the dynamic data, and the real-time data is what we get it, right? And also this is not only the billing. So let's say if we want to have some predictive maintenance. So because let's say we want to do the transformer maintenance. So any engineer, he can able to log into the system and see the historical data. So he can able to see how the transformer performance was in the last 6 months, and what was the temperature, what is that oil level it is containing, and how the control circuits are doing, and how the breakers or everything. As these data, it is all digitalized, and it is stored in the either in the SCADA system for the processing, or as the historical data, it has been stored in the cloud for the further process, right? So engineer simply has to log into the system and check. Okay, they can able to take the decision whether this transformer or else any of the circuit breakers needs to have the maintenance or not, right? So basically what we are trying to achieve here is, instead of reacting reacting, this was the approach what we are having. So we are doing the proactive approach. So in the reactive approach, what usually in the legacy system what we were doing, if something breaks down, let's say if some this specific component in the device layer is failed, after that we will be reaching out from any maintenance department, and they will be replacing it, right? So it is all about the wait and watch. So the device has to fail, then only we can able to do the maintenance. That is what the approach was. But now in the smart grid technology, it is all about the predicting. So before the system or the transformer or any of the system fails, we predict before that. So when we predict this type of the events, we can able to reduce so many blackouts. We can able to give the customer the good service what they need, and there will be an improve in the power quality, and so on, right? So this is all about the structure, right? And other part is, if you see these arrows, let me wipe this out. Yeah. And if you see these arrows, right, the blue arrow, this one, so this is all the data flow. So the data always flows from the bottom to top layer. And here if you see the control commands always flow from the top to the bottom. So the control command is the decision making, the input which we got it by processing the data in the cloud layer, or else we can able to process that also in the this control layer, the SCADA. It depends upon the implementation or the use case, right? So all the commands will be given from here, or else from the cloud. Then this the control commands will be executed in the field level, right? For example, let's say you want to increase the production, or else like you want to have a certain degree of the maintenance on the specific devices. So based on the data which we had collected, so data will go here, it will be processed, and the control command will be given from this to this. So this is how the smart grid works, right? So let me pause for a while. So anyone having any doubts here? Any questions? No questions. Okay.
Sir, where we have to use in day-to-day life, sir.
Sorry.
In this block,
Uh-huh.
where we have to use in day-to-day lives.
Day-to-day life, huh? Okay.
Yes.
So these are all will be implemented in the substations, okay? Major substation, or else if we have now the concept is all about the microgrids, correct? So it is almost implementing, not in India, but in the Western countries, it is already implemented, correct? When it comes to the day-to-day activities, let's say we are having one substation. Let me draw here. So one substation, correct? So substation here, and so this assume that this is running on a legacy. Legacy means older equipments, right? So now you have to make this as a the smarter devices. So what we will do is we will add the sensors, and we will add the smart meters, and so on. Now, when we add these components to these legacy devices, right? For example, in the transformers, we are adding CTs, PTs, advanced sensors, advanced temperature, and so on, right? So from there, we are taking the data into the SCADA system. So SCADA system is supervisory control, correct? So it will have all the details about this transformers. So it will be keeping all the details, and it will be processed, and the processed data will be sending to the cloud. Let's take an example of AWS. So this is a day-to-day activity every day, because transformer will be live 24 by 7. So it will not go offline, correct? So this the process is that every day happening. This is what and also the processed data from the AWS, it will come back to the SCADA. There will be a decision making, and then the control or commands will be given back to the transformers. So this is one of the real-time example what we are having. It is not only limited to the substation. It could be an solar power station. You might have visited any of the solar plants, right? So there will be an different panels where they might distributed across the acres. So what they will do is, so there will be a main SCADA system here, and these panels will be interconnected. So this is how it will be, and there will be small control circuits everywhere. So what this will do is, this is called as RTUs, the remote terminal units. So these terminal units will fetch all the information about this specific the panels, or else like any control unit, and then that will be sent back to the SCADA system. Same thing from the SCADA system, we are processing the data, or else dumping all the data in the database, and the processing by using the Gen AI. Okay, so this is what real-time example what we can able to see, right? So is it clear?
Yes, sir. Okay.
So this will make sense if you visit any of the power plant, or else like specifically if you visit solar plants, right? Why I'm mentioning specifically solar plant, because nowadays solar installation is all new installation. So solar by mandatory, they will be having this SCADA system with advanced system, so that if you visit and ask them, can you explain the SCADA system, they will beautifully explain you, and they can able to show you the components, how the data is processed, how the command is given back. Probably you might have seen the solar panel tilting based on the sun direction, correct? So everything is automated. There is nothing called the manual currently. So these the panels will be tilting so that it will face the sun direction based on the time. So this the command also processed in the SCADA system, right? Okay. So we spoke about in terms of architecture. Now we will focus mainly on the SCADA system, right? Okay, just a minute. Okay, so um, we will talk about the SCADA system now. Yeah. So the SCADA system. So we saw it in the layer, right? So this is we can call it as in the backbone of operational control, right? So the SCADA, it is the supervisory control and data acquisition. So name itself suggests it's an control and the data acquisition. So the meaning of acquisition is like the getting the data. If you see here, as I explained in the previous slide, right, we are having these uh,
Madhu sir,
ha sir, ಹೇಳಿ.
screen is not visible, sir.
Screen is not visible.
Yes, sir.
Is it the same for everybody?
Visible,
No,
sir,
sir.
visible.
It's visible, sir.
Visible, okay. So I will reshare once again.
Okay, sir.
Is it visible now?
Yes, yes, yes. No, it's visible, sir.
Okay, great. Okay, okay, let me put this here. Great. Yeah. So yes, where I was, supervisory control and the data acquisition, right? So this is the backbone of the control unit complete. So now, so what is the functionality when it comes to the functionality? So it is all about the real time. Yeah. So it's all about the real time monitoring. So every 24 by 7, and we can able to set the timings. It could be every 1 minute interval, or else 5 minute intervals, or 10 minute interval. So these the intervals we can able to set it in the SCADA system for the real time, the grid asset monitoring. So when I say the grid asset, it could be an control unit, it could be in transfer, it could be in transformer monitoring, and so on. There will be different components within the substation, right? It could be an circuit breaker also, correct? So this is all the real time monitoring is what we need. And to do the real time monitoring, so basically we need what is it, the parameters like the P, Q, and also the V and the frequency, right? So here everybody knows, right? This is the power, the reactive power and reactive power, the voltage and the frequency. So when we have these parameters calculated at the regular interval of time, so and these the parameters also collected from the thousands of nodes. So it could be, it is not only the single substation what we are having, correct? So it will be an many thousands of substations. So when we have these parameters in the real time, we can easily calculate what exactly the power quality is, if there is any variation occurring in the substation, and so on. So that is what we will get it. That is one thing. And second important the component, or else like so use of SCADA is remote controls. Sorry, it is all about the remote control, right? So we don't have to go to the physically go to the site inside the substation and take out the breaking. So everything can be able to do that from this the control and the monitoring station. In this control and monitoring station, what we are having a, it's in SCADA software which will be running, and this will give the command. right? So this will give the command to the circuit breaker telling that, okay, please open or the close automatically. No physical intervention is required or nothing. So simply anyone, the operator can go and they can able to, without going there, they can able to the break or the make the circuit. This is what we are having it. That is one thing. And also the alarm and event management, right? So here we are utilizing the logic based triggers. Logic based triggers, the name, see, the logic based triggers. So let's say for example, uh, we can able to set the parameters in the SCADA system such a way that, for example, if some fault occurs, or else if there is an overload, or else equipment malfunctions. Let's say this is the almost oftenly occurred problems in our substations, right? Equipment malfunctions. So probably we might be having some control units placed in the HT panel or LT panels in the substation, right? So there will be some certain the malfunction happening in the system. So those malfunction that will be the logical based, and that will trigger the alarm, and based on that alarm we will take the decision what needs to be done. Correct, whether this complete the panel needs to be isolated, or else what exactly happened behind the scenes. So this is what uh, so just a hold on, just a minute. So my screen is still visible, right? Am I audible? Anyone? Is my screen still visible? Am I audible, guys?
Yes, sir.
Okay, fine. Um, yeah, this is what so we are having, and the remote uh, alarm and remote unit management, right? Then now, so after this, we also use that for the historical data collections. So we spoke about the data collection, data acquisition, right? So every minute or else every 5 minutes on a regular basis, and a regular interval of time, we are collecting the data from all the nodes. So everything is called as node here. Node means the specific device, right? So this is what we are having, and everything is stored in the database inside the uh, SCADA system, and then it will be moved to the cloud. So this is how the SCADA system backbone will be working. And so yeah, I think that's all about the SCADA system. So anybody having any questions on this? Okay, so if you come and ask like who are the major OEMs, so we call it as an OEMs, original equipment manufacturing, right? So basically, we have the Siemens, we have what is it? Uh, ABB, and we have Rockwell Automation, and also we are having, so other, there are many other OEMs who design and provide the SCADA systems, right? Okay, fine. So, guys, let's take 5 minutes of bio break. Okay, we'll come back at 7:55. Okay, so we will start once again, right? Okay, let me share my screen. Okay. Okay, so let's talk about the the components of the SCADA, the core components of the SCADA. So my voice is audible, right? Can anybody confirm?
Yes, sir.
Okay, thank you. Fine. So we got to know about what exactly the SCADA system is, and how the SCADA system works, right? In a very high level. Now let's go in the deeper side, where we will get to know what exactly the components of the SCADA system, right? So if you see in this diagram, right? So we have, let me select the pen here. Yeah. So as we spoke earlier, we have the field devices, right? And also the IEDs and the RTUs. So these are also very important the components, the devices we will be using in the SCADA systems, right? And the IEDs are called as intelligent electronic devices. Let's say it could be an relay, it could be an breaker, but it should be of the latest generation of the devices, right? And coming to the RTU is remote terminal units. So these are all the units where we used to acquire the data. So basically then data collectors, what we can able to do it. And also we have other set of devices like the PLC, the programmable logic controllers. Even these, many of the installation site, if you see, we can able to find the PLCs. So most of the time the PLCs can be found inside the control unit, right? So if you open any of the control unit, you can able to find these PLCs in the substation or any of the control rooms, right? That is the one thing. And yeah, so basically, okay. uh, and other type of the sensors, yes, the sensors we already spoke, CT, PT, and other kind of sensors we are having, and these devices are called as the brain of these systems. So these are all the very vital roles, right? And if you see, let's take an example of the solar installation, right? So if you see, solar installation will be spread across 10 acres, let's say, right? So if you can see, this will be like very much big, and there will be a cluster of solar installation. This could be in one cluster with all the solar panels here. This could be in second cluster of all the solar panel, and this could be in third and fourth clusters with the panels. Correct. Now, these IEDs, or like RTUs, IEDs and RTUs will be installed across this the clusters, and then these clusters will communicate with each others. It could be a ring or else mesh. So if we say mesh, then uh, let's say this is our control control room, and this could be an small, and if this kind of the design has happening, this is called as mesh. If this is like, it is called as ring topology, right? So this is one of the topologies what we will be using it. And the second part is how these panels are connected. Panels, or we can able to call it as an small units, will be connected from each other, as well as to the main, the control, the master station, we call it as a master station, right? So basically we will be using the fiber, or else ethernet, or else we also have this RF. So I will talk more about the RF in a minute. So we have the ethernet. Ethernet is for the 90 meters, as we spoke last class. So it is limited to the 90 meter, and ethernet is of the copper make. So when we take this use case where the solar installation is spread across the 10 acres, right? So this is having the limitation of 90 meters. We cannot use this. Instead of that, we can able to use the fiber, where we have the single mode fiber and the multi-mode fiber. So single mode fiber go up to 10 kilometers. The multi-mode is having the limitations of 500 meters only, right? So by using these the communication network, we can able to take complete data from the field, and this will be sent to the master station. So in the master station will be having the SCADA systems, right? So it will be processing. And so one more point is, so these fiber or Ethernet cable will be buried under the ground, right? So, and also the second, the point we have to take care is the EMI. So this is very much important concept, where it is called as electromagnetic inductions, right? So for example, if we have multiple cables running from multiple RTUs, so if you say you have 10 RTUs within the same facility, so you cannot run the same cable in the same path, because so when you do that, there will be an electromagnetic induction. And also you cannot club the data cable with the power cable. When you run these two as a bundle, so because of the EMI, the data which is carrying either from the Ethernet cable or the fiber, there will be the problem where the data might get corrupted, because of the EMI, because the data is all about zeros and ones, correct? So this is how the digital data looks like, and this data will be packeted, and it is channeled through the cable. It could be an Ethernet or the fiber. So when you are running the data and power cable, these the data can miss out, or else it can get corrupted. So it is always recommended, and it is always the good practice. The data cable should be in the other lane, and the power cable should be in other lane, or else in the other trench, and this is should be in the other trench. So this is often as in standard, and if you go anywhere, they will first ask about the EMI. If some senior person or some substation guy, so when you ask them about this, right, they always talk about the electromagnetic induction problem, right? This is one. Let me wipe this out. Okay, yeah. So now the third and the most important, the latest technologies what we see in this the large facilities are the RF, right? So the radio frequency. Let's say this we this facility is very far, up to 5 kilometers or something, and you have to communicate the data which is generated from the field devices. So either you can able to communicate to the master station by using the cable. If there is a constraint telling that you cannot lay the cable, then what is the other option is by using the antennas. So there will be one. So this is the Wi-Fi outdoor type, and we will configure one is sender, and also we will be having the receiver at the master station. So in the similar fashion, we can able to install multiple senders, RF. So what these will do, this will communicate to the receiver. So we can able to configure these in the mesh. Correct. You can able to have multiple sending devices, and let's say you might have heard about Cisco. So Cisco makes these devices, the outdoor Wi-Fi devices, and also we have the HP Aruba, Ruckus. So these are all the major OEMs who makes these devices, and we can able to purchase those devices and install in the field site, and then we can easily communicate the data from the field devices to the master devices, right? So this is one way, and let's say there is other option. So if it is too far, right, and also you cannot able to install these uh, Wi-Fi devices, what we can able to do is we can able to utilize the 5G or LTE service which is available in the area. So you can able to make an agreement with the telecom sectors telling that, so we are having this kind of use case, and what they will do is they will allocate a specific bandwidth or a specific wavelength we can able to utilize and can able to establish the communication between the field devices and the master station. So these are all the components what we are having now. There are three ways, right? We spoke. It is the fiber, it is the RF, and it is the 5G or LTE. Now the requirement is whatever the connection what we are establishing between the field devices to the master devices, the latency. So it has to be 20 to 20 milliseconds. So this is very, very important criteria. So if we are not meeting this criteria, we may face some, reliability issues, right? And the data may not be useful at a certain point of time. So whenever we design a system, we have to make sure that the latency is very, very less. It is 10 to 20 milliseconds. This is the must. And the second criteria is it should be high availability. So high availability is, for example, this field device having if this devices fails, then what is next? Uh, the complete system will fail, which is coupled with this, correct? So we have to make sure that even though one device fail, the other device will pick up the signals or else the device, the parameter from this unit, right? And also the cabling or else RF, make sure that if one cable goes down, right? So there should be other backup. It can be called as a standby cable that needs to be taken care of the data movement from the field devices to the master station. So the two criteria, one is the latency part and the other one is the high availability part. So high availability, it should be 99.99%. It is what is recommended for the SCADA system design. Correct. Okay. So coming to the master station. Yeah, let me wipe that out. Yeah, so the master station. So this is where we are having the the processing unit, everything, right? This is the master stations where it will receive all the data from the field devices. So here also same thing. So here what components we are having? We will be having, one is SCADA server. So the SCADA server, this server will be set up as in cluster. So it will be not be a single server, it will be in clusters of server for the high availability. So server, think like an, the more the powerful computers which will be installed in the data centers. So that is responsible to acquire the data, the process the data based on the logic what we will be defining, right? And also we will be having the databases within that, and also these databases is also on the high availability. So we are designing a system such a way that it should be the fail proof. Even though one db fails, the other db is available for the service, right? This is one. And the second component inside the SCADA system what we are having is HMI. So this is human and machine interface. Basically, here everything you can see the graphical interfaces, right? Graphical display of the grid. So which within this HMI we can able to see the single line diagram. We also call it as an SLD, right? Single line diagram of the complete. It could be a substation, or else it could be an the solar plant, or else any of the hydro. So we get the single line diagram within this system. So when we have this single line diagram, it is very much easy for us to interpret what exactly the system is and how system is designed, which component fit where. Correct. So this is where we can able to see the single line diagram. And also this single line diagram will give us the status, like there are the status called healthy status, and like alarming status. So these are all the flags we can say, right? So these are all the flag which can be seen in the SLD, and the operator, he can able to simply address the problem. For example, if we have the alarm within the transformer, he can able to go and fix that issues, right? So this is the important part of the SCADA system within the HMI. And yes, so as we talk about the database, right, the historical data, very so every minute we are collecting the data from the RTUs and IDEs, right? So it, the data will be stored, and also we have to be ensuring that these data can be restored for the longer time. And also we have to make sure that there is a concept called RTO and RPO. RTU and RPO. So these are all the recovery time unit and recovery. So basically, if something goes down in the system, how fast the system can be able to recover, that is one point. And how far, how well, and how good we can able to recover the data lost. So this is the concept behind the SCADA system and the components of the SCADA, right? So this is what the inside the SCADA system looks like. So anybody has any questions? Okay. Okay. So let me finish this. Okay. So just a minute. Okay. So yes, so this is the very simplest representation. So you can able to see we have the field devices right here. So these could be these could be where it is. Yeah, yeah. So these could be and the PLCs, IDEs, and so these are all the sensors, RTU, and then these sensors will be terminated to the RTUs where we collect the data, right? We collect the data from the field devices, and these RTUs are connected to the main terminal unit. That is the SCADA center. This is called as the master controller, right? So this is connected via wireless, the optical fiber, and same thing, right? So this is very simplest diagram so that we can able to understand what exactly is happening. And yes, the field instrument level, the process level, and the supervisor level. So this is where we can operate by using any of the system which is connected to the our database and also to the server. Server is used to compute and database used to store the data. Correct. Yeah. So coming to the data acquisition flow. So this is very much important concept where we talk about how the data acquisition will happen, right? So let's say we have the sensor, correct? If you see here in the in the first part in the first point, the sensor measure the physical parameters, right? So data acquisition will happen in the five steps: one, two, three, 4, and 5. So in the initial step, we have to measure the components, right? So to do the parameters measurements, what we are going to do is we are utilizing the sensors, right? So what the sensors will do is sensor will take uh, it will just measure the required parameters. Let's say the voltage, it could be an frequency, it could be a current. So basically it will be a kind of analog system, right? This is what we are measuring by using the sensors. Now we cannot use this analog signal, correct? It has to be changed to the digital one. So to do this, what we will be using is RTUs combined with the IEDs. So what this device will do is this device will convert the analog signal into the digital. So we always process zeros and ones. Correct. We cannot process the analog signal. So analog signal is it we don't process as of now. It is not efficient now. So we will converting that analog signal into the digital signals. And to do that, so we are using RTUs and IEDs. And also the important part when we digitalize these data is we are putting the timestamp. Correct. So this is what the critical, because so this the measurement is in continuous process, correct? So at a regular interval of time, it could be in 1 minute or 5 minutes, these signals will be coming to the device at a regular interval of time. Now if we don't have the time step, how do we measure the sequence, how do we collect the sequence of the events, correct? So it is always important that we add the timestamp. So the by default the RTUs and IDUs are very much smarter. So whenever they receive this analog signal, they will put a timestamp and they will do the digitalization, right? So this is what the digitalization. Now we have converted the analog signal to the digital signal. So now we just have to transmit the data, correct? So to transmit the data, so we cannot transmit the this data simply as it is, correct? This has to be encapsulated. So we use the protocols like IEC 60870, and or else we use DNP3. So we will see in the depth what exactly these the protocols are. So what these protocols will do is these protocols will encapsulate this digital data which is produced by these analog signals, right? So, and also this is where we are securely transmitting the digital data to the our processing units, right? So now we are encapsulated, and by using some cables or else RF or else 5G or LTE, we are transmitting that encapsulated data to the SCADA system. So now the SCADA system will, what it will do is it will validate this the digitalized digitalized data, correct. So once this SCADA system receives these packets, it will see, it will check. So basically we will set the limits, right? Limits and alarms and so on. So basically we are setting the threshold within the SCADA system. So this SCADA system will be compared with the actual. So if the packet is equals to the alarm state, so SCADA system will raise the flag telling that specific device is it's in not normal stage, take an action. Okay, this is how the SCADA system will compare the set limit versus the actual data. So it's everything will be on digital, and this is how the alarm will set on and off. Now, so basically, once the SCADA system has been compared with the digital data what we have received from the field devices, it will compare and it will give one action. Uh, let's say there is some threshold, take some action, and it will send an command or notification to the operator in the control action. So operator can able to take necessary action. Let's say he wants to break the circuit, or else he wants to isolate certain components within the system, or else like if you want to just monitor the system for the further action. So it is monitoring. So based on the required alarms and the set limits, the operator can able to give the command to the system telling that what necessary action needs to be performed, right? So this is how the data acquisition will takes place. From the analog, it will be converted to the digital. From the digital, it will be encapsulated by using these the protocols we are having, and these encapsulated data will be transmitted to the SCADA system, and the SCADA system will raise the command or else give the notification to the operator to take the necessary actions, right? Okay, yeah. So this is the data acquisition flow what we are having. So anyone having any questions?
No, sir.
Okay. Okay, so and the other one is very important concept where we talk about the protocols what industry use, right? So in your syllabus there is three important the protocols what you guys has to study. One is DNP3, other one is IEC 61850, and other one is the Modbus. So we will be deep diving in these three modules and the protocols, right? So before going that, so I want to explain very important concept. So if you go to any of the system or any of the company or anything, so day to day life, right? So there is a concept called OSI model. Concept called the OSI model. Okay, so I request everyone in the class to just think and read these OSI model, because this is the basic of all the communication, all the protocols, how the server and the client interact with each other, and also how the device A communicate with the device B. So this is the basic. If you know this, you can able to design a complete communication systems, the SCADA system, the smart grid, and whatever it is. It could be in software, it could be in anything, right? So this is the key important concept, the OSI model, and I request everybody to spend more time on understanding this OSI model. Okay, so now, what exactly this OSI model is? So this is the model which was proposed for the communication, to establish the communication between the two devices. It could be a server, or else it could be between the two computers or the devices, right? So basically what we will be having is, we are having the seven layers here, seven layers, right? So starting with, we have the physical layer, and the data link layer, and the network layer, the transport, the session, and the presentation and the application. So if you see the physical layer, it's all about the cables and the hubs. It could be an RJ45, or else it could be an fiber, and the so on. So this is where the physical transmission of the data, zeros and ones will takes place, right? So this is the physical layer which used to transmit the data from the one devices to other devices. You can see these are all the LAN cables, correct? And then in the second layer, we have the data link layer. So this is very much important. So this is where we have the concept called the frames. Okay, so if you see in your personal computers, there will be a simple the NIC card, network interface card. So in any of the server, if you see, there will be a small terminal called the NIC card. So where you can able to connect one devices to the other devices. Let's say if you want to connect this NIC card to the network switch, this is not the actual circuit breaker or the electrical switch. This is all about the network switch, correct? So this operates on the MAC address. So every device, every SCADA device, every field device, so we'll be having the smart sensors, right? And RTUs, and we also have IEDs, right? IEDs. So how each everyone will have the different address in the field. So let's say we have the RTU1, IDU1, and RTU2, IED2, right? So how do they communicate with each others? So these will have the MAC address. MAC address is the manufacturer provided address. This is the physical address. If you open any of your network devices or any of the latest technology devices, right, everything will comes within the MAC address. So this is the physically embedded address which comes along with the devices, right? So this will help in identifying which device belongs to where, and what is that device specifically called, right? So this is what the MAC address is. And coming to the third layer, so the network layer. So basically, this is the packets, correct? So this, for example, we have this MAC address, correct? And the MAC address, along with the MAC address, we will assign an IP address. Let's say 10.10. Or something, or 192, so something. So this is an logical address what we will be giving to the specific devices, right? IP address. So this IP address, we have the public IP address, and the private IP address. So public IP address, so anybody from the internet can able to reach to a specific device. Let's say if this RTU is having the public address, anybody from the internet can able to reach to this RTUs, but it is not recommended, because if this is exposed to the internet, anybody can able to log in and do some problems to the system, right? So we never do that. What instead of that, what we will be doing is we will be assigning the private address. Let's say we have one device here. We have one the device which is inside. This is, think like this is the edge router, and these are all the field devices, and these devices will connect to the routers, and the router will be connecting to the SCADA server, and also it is connected to the internet, correct? So internet. Now, so let's say this is having some, we never assign public address to the field devices. It's all private, correct? So when we assign this private, only these system within the this the router, he can able to communicate with each other. This can able to talk to this field devices, able to talk to the server can able to send the device to the field devices. But so these devices will not have the internet connectivity, because the router will block this IP address, because these are all the non-routable IP addresses. So if you want to have the internet IP address assigned to a specific services, then we need to have one NAT gateway. NAT. So network address translation. So for example, if we have thousands of field devices, right? So let's say for some use case, these device needs to communicate to the internet, and also the SCADA server wants to communicate to the internet. So what we will do is we cannot purchase the public address for these thousand devices, right? Instead of that, what we will do is we will purchase one single public IP public IP, and it will be given to the router. It is called as edge router. So what this will do is, if this specific field device wants to communicate to the internet, it will come and it will say, okay, I want to communicate to the internet. So what it will do is, network address translation will convert this the private IP into the public IP. It will mask it, okay, and then the packet will go into the internet to the specific destination, right? And that is one thing. And when the packet comes back from the destination or the server, what the router will do is, router will translate back to the private address from the public IP. So this is how the communication will happen from the on premises to the internet, right? So this is how flow is, and this is where the network layer comes into the picture. So where the router will come, and so the filtering of the packets we can able to do it. For example, let's say the specific range of IP address, so 10 dot 1 dot something, so we can able to restrict in this specific router, okay. This is all about uh, the layer 3, and Anybody has any questions till now? No. Good.
Yes.
And uh, when it comes to the transport layer, so the transport layer is like we have an TCP and also we have the UDP, right? Basically, this transport layer, what it will do is, for example, we are having the routers, right? So this is like substation one, substation one. This is substation two. Consider it. So how do we make the communication between these substation one and two? So we need to have the edge routers, edge routers. So it is also known as the perimeter routers. Okay. So initially this will be having the public IP. Even this will be having the public IP, and based on this, these two will establish the connectivity between the two, right? And this connection is encrypted. So we call this as an IPsec tunnel. Okay, IPsec tunnel is the encrypted the connection between the substation 1 and substation 2. Why we required this encryption between these two router is, so let's say, because this the encryption will happen through the internet, right? So the router will connect to the substation via internet. So internet is not safe, so we have to encrypt our the data, correct? So for that reason, we are doing that, we are establishing IPsec tunnel from the substation 1 to the substation 2. And anybody can able to spoof into these packets. He don't see any of the destination IPs or else the source IP or the payload within that IP packets, right? So these are the IP packets. He cannot able to do much using that the packets, correct? Though this is what the layer 4 will be doing it, the host to host flow control, right? And we have TCP and UDP. So TCP is very reliable because even though the connection fails, the system will re-establish the communication. And the UDP, if the some packets drops, then it will not try to regain that packet, right? So this is all about the transport layer. And if you see the top three, correct? This belongs to the application layer. So the session, the presentation, and application layer. So let's take an example. So when you click on any of the browser, right, in your laptop, so it it will open an HTTP page, that is the application. It could be HTTP or else HTTPS, that is a secured one. Then what it will do is, so it will prepare what exactly you need as an in the presentation layer, and then it will create in sessions to sessions from this server to the client or else the host or something like that. Okay. So once this session is established between the two devices, you can able to the transmit the data, actual data, right? And the bottom layers is all about the establishing the connectivity, and this top layer is all about the exchanging the data, correct? So the application layer can be in, HTTP, HTTPS, SMTP, and so on. So, and this is where you can able to see very, very high level how the device able to communicate. So I request everybody just go through it. It is very very important topic, and wherever you go, it is implemented everywhere. So whatever we are having the call right now, right? It's all about these layer models. So if you know this concept, then it is well and good. Okay, and we'll do one thing. So we'll take a break. uh, we'll take 1 20 25 minutes of breakfast, and we'll come back, and we will cover a couple of other topics, the protocols, and we'll wind up the today's session. Okay. Okay. Um, okay. So with the interest of time, we'll start. Okay. So Snake, can you just confirm whether my screen is visible?
Yes, sir, it is visible.
Okay. Thank you. Okay. The recording. Yes. Recording is started. Okay. So in your syllabus, we have to cover three main topologies. Okay. So first we'll start with the DNP3. So the DNP, so it stands for Distributed Network Protocol. So these are the protocol which are used to communicate with the master and the node. Okay, just give me a minute. Okay, yeah. So the DNP protocol, which is used to communicate from the master stations to our field devices, right? It could be an RTU, or else it could be an intelligent equipments, right? So the purpose, as I said, it is to communicate, to establish the reliable the communication between the control center to the RTUs. So let's say coming to the technical part. So this is an open source and the public protocol. Initially, it was used in the North America, North American electrical and water utility industries, right? So basically, it was designed to bridge the gap between simple IT protocols and so the IT initially the IT protocols which was designed, it is only for the close environment, so it was not designed for the harsh environment. So we will be having the substations and control units, the master stations, so they are built outside, and this is for the harsh environment. And also there was an probability of leak of data, anybody can able to breach into the property and can able to take out the data, right? So there was a limitations for the existing the conventional type of protocols, right? For to mitigate that, so what they did was they introduced DNP, that is distributed network the protocol, right? So that was the main intention of that. And so basically it is based on the three layers, that is one is the enhanced performance architecture. So which this is also one of the part of the OSI model which I was discussing earlier. So basically coming to the key features, it is an event driven, right? So what it will do is it will just give the reports only, the changes, what is happening in the system or something like that, right? So what basically what it will do, it will be doing is this protocol instead of polling. So for example, this is 24 by 7, 24 by 7 is what we need to monitor this, correct? And also these master stations should receive the data 24 by 7, correct? So instead of polling the data every minute and every second, so probably this master station wants the data to be polled. So when I say polling, it is to fetch the data from the field devices to this the control station, right? So what will happen if we continuously poll the data? So one is the bandwidth, correct? Bandwidth will choke. So for that, what they have done is only the reports only changes. Let's say if some changes happen in the RTU or any of the any of the field devices, the changes only that changes will be pushed to the master station, right? And also we have other concept called SOE, that is the sequence of events. So basically what it will be doing is it will keep the database of the sequence of events, right? It will keep the database, and if something happens, the fault happens, or some like the device is not performing as expected, so these changes in the field devices will be recorded in the station, and this is called as an SOE, and this will be used for the analysis purpose, right? And and this is also the based on the CBD, that is called as class based data. So this will be organized as a classes. So this we call it as a classes, for example 0 1 2 3, three classes. So basically what it will do is, so 0 1 2 3 is in criticality of the alarm over the time of telemetry, right? So when you set these classes, for example 3 is very high and the 2 is little low compared to the 3, and so on, correct? So when you set these parameters, whenever the changes happen in the field devices, the master unit, what it will do is based on the protocol, so this will check these the class based data, and it will trigger the alarm. Okay, so this is what the DNP3 is used, and majority of the time this protocol is used between the master station and the RTUs, right? And the strength is it is very excellent for the telemetry data. So you might see telemetry data all the time when you design a system, or when you are talking with any technical person, right? He always talks about the telemetry data. So telemetry data is not the actual data, so it is a part of actual data, so it is kind of indexes, right? It is all the telemetry data, and so this will only the fetch the required data only. Okay, that is one thing. And so yes, these are all widely used in the legacy grid. So basically this is not implemented now, so now it has been replaced with the more good protocols, I can say, right? So this is one thing. And coming to the limitation of these the protocol is, so data modeling, we cannot do much data modeling from this the protocol. So when I said the data modeling, like so we want to analyze the data which we get it from the RTOs, right? And also we so it is not that much flexible to adopt into the latest generation of the AI and ML models, right? So there are like certain limitations. And also if we have milliseconds, sub milliseconds logics, so it is not suitable, because like if you say there is very critical component which is in the system and it requires the sub millisecond responses, correct, it cannot be able to do it. So these are all like certain the limitations what we are having. And also this is based on the TCP IP model, correct? So OSI model, it's also known as the TCP IP model. It's a smaller version of the OS model. And so this is how the communication from the RTU to the master station will take place using the DNP. Okay, this is one of the protocol, but these are all implemented in the legacy system, not in the latest substations, right? Okay, and this is one. And moving on to the next one, the IEC 61850. So this is the actual the modern the protocol what we use currently. And so the purpose, so coming to the purpose, it's an modern, its key important is it's an object oriented substation automation. So if you go to the any of the substation, right, so they they will be implementing this IEC 61850. So basically it is an object oriented protocol, what is what we can able to say. So it is very much used and it is very much helpful in the data modeling, right? And coming to the key innovation, and innovation is like the logic devices, logic nodes. So these are all the logic device. It's a cluster of logical nodes, right? These are all called as the logical nodes. For example, we have a breaker, we have a transformer. In the breaker we have the position mod operations, and then a temperature level tap, and so on. These are the parameters what we will be monitoring and fetching the details from these logical nodes. So what it will be doing is, once we fetch these logical nodes from the logical devices, so we have communication types. So we have three types. One is MMS, so that is the server client communication, correct? Other one is goose, that is event, and SV is the stamp value. Basically, so substation automation is where we implement this. And for example, so MMS is like manufacturing message specification, and it is very much common used for the vertical communication between the substation bus and the IEDs. So this is where so basically if we have the field server or the client, which this MMS will enable the communication between the server. So this is where the one of the part. And the second part is the goose, that is generic object oriented substation event. This is called subject generic object oriented substation event. This is very high speed communication between the peer, that is IEDs, or else it could be any of the substation server, right? And if you see the speed, it is less than 4 millisecond. It is very very fast. So this goes will help us to establish the communication at a very high speed. So that is where the goose come into the picture. And second part is SV, that is sampled value. So what this will do is, so this will digitalize the analog form. Basically we only get the analog signals from these breakers and the transformers, right? So this sampled value, what it will do is, it will convert this analog form into the digital digital format for our data processing and the data modeling. So basically combined with the MMS, the goose and SV. So this is the latest the protocols what usually the latest substation, or else any of the installation, electrical installation, or the renewable installation, you can able to find this IEC 61850, right? Yeah, this is one of the protocol. And yeah, so if we talk about the strengths and limitations, so coming to the strength, this is extremely fast, the protocol, right? And also it is used for the protection, because we can able to do the encryption, correct? And also we can able to use the different vendors. For example, if we have the breakers of ABB or Schneider or Siemens, right? So based on based on this specific protocol, we can able to utilize the different vendors breaker, and they can able to talk to each other. So it is called as interoperability, is what we call it as an industrial terms. And this is based on the ethernet. Okay, it is not the serial communication. So if you go to the this one DNP, it is in serial communication what we are having. And if you come to this, the IEC 61850, it is all about the uh, ethernet, right? So the speed will increase, and the data transfer also it will be increasing, right? So this is one thing. And coming to the the limitations. So when it comes to the limitations, as this is in very latest the protocols, the implementation takes time, and it is very complex to understand the protocol, and it is also very much complex to implement. Only the skilled engineer who knows the well about this IEC 61850 can able to implement within the system, correct. And also the last part is it is required very much higher infrastructure cost. So the amount to install and amount to procure this the technology is way higher compared to the legacy one. So these are all the limitations what we are having in the IEC 61850. So these are all the limitations and the features about this specific protocol. Okay, this is one thing, and yeah, and the third part is the Modbus. So probably you might have heard the Modbus in various design or various substations, right? So this is kind of very legacy one. So currently it has been obsolete. When I say obsolete, it has been ignored for the latest the deployment, or we can able to say integration part, right? Why? Because this the Modbus was one of the earliest developed protocols, right? So it was found in 1979. So it was implemented across the various industries. It could be a manufacturing industry, or else it could be an any of substations, any of the installation where we required the communication between two devices, right? So the Modbus was the preferred one, but it was kind of legacy one. Even in the SCADA system, if you visit any of the facility, currently the SCADA system where we have the master and slave architecture, correct? In that, so this Modbus technology has been implemented, but the problem here is like there is no time stamping one thing, right? So if we don't have any time stamping, we cannot uh, analyze the data. So we if we want to say okay, this specific data on which time it was, the timestamp within the packet, it is not present. So because of that, there are limitations to analyze that data and do the data modeling out of that details, right? And that was the one limitation, and second limitation was the no encryption. So as we don't have any encryption on this specific Modbus, it is very high risk, right? If anybody could able to get the access to this, they can able to fetch the payload. When I say payload, inside the packet there will be an space we can able to put the actual data, correct. It actual data, it could be an the sensor data, or else the smart device data, those data. When the bad actor can able to fetch this one, it will be problematic, right? So that was the biggest the concern what we have in the Modbus, because we don't have any encryption. This is what we it is essential as of now, and as per the compliance also, we need to implement the encryption, right? That is the one of the major drawbacks what we are having in the Modbus. And so and also, so coming to the data types what we are using, correct, it will be an discrete inputs, like say signals. It could be an on and off. So only the discrete signals is what we get it from this. So hold on. Yeah, so only the discrete signals is what we get from this Modbus. Okay, and the the good part is like it is a vendor agnostic. So I was mentioning earlier. So even if we have the different OEMs, that is ABB, Schneider, or Rockwell Automation, if we have the devices from these different vendors, we call it as an OEMs, correct? So we can able to configure these devices, and and also these devices can able to talk to each other through the Modbus technology. Correct. And so it is very much easier to implement compared to the earlier the protocols. So the Modbus and the skill set uh, required to implement the Modbus is very less, and we will get the engineers who knows the Modbus and the implementation of the Modbus. So basically we can able to find lot of installation having the Modbus even in the industry or in substation and so on, right? So this is what the strength, and yes, the limitation we already spoke. It don't have any encryption. The time synchronization is very difficult, and it is registry based. So uh, so that is what one characteristics what we are having. So yes, so these are all the three the protocols what you have in your syllabus. So these are all the the communication protocols what we will be implementing in the SCADA system, and also to communicate between the master and slave, either or else we can call it as an substation to the field devices, right? Yeah. So this is all about the protocol. So anybody having any questions in these three topics? No. Okay. So now what we'll do is, so we got to know what exactly the SCADA is, what are the components involved in the SCADA, and also like how the protocols work together, and what are the different protocols for the communications what we use in the substation as well as the SCADA systems, right? Now, so we will talk about the the top layer now, correct? So if you see the legacy and the latest technology, right, and it is all about initially it was what is happening, and from that we are moving towards what will happen. If you see the difference, so initially we have to react. It was all about the reactive approach, right? If something breaks, then only we will get to know, okay, that specific transformer or else the LT panel or HT panel, the control units have been failed or it is malfunctioning, right? Now we are moving towards the prediction part. So it is all about what will happen. Correct. So how do we do that? So as I was talking previously, this will happen when we process the data which we get from the field devices, right? So in the next class, what we will do is, so we will talk more about the processing in the cloud. So it will be more talking about the processing and AI models, and in the AWS, what are the functions we use in the real time, right? If you say any specific industry, it could be in manufacturing industry, or else it could be in pharma industry, or the electrical vendors, or any of the power distribution vendors. So how do they consolidate all this massive data and process it? So in the next class we will focus on the processing of these data, but it will be in the cloud. So the cloud, the software what we will be using is the AWS technology, and in the next class we will see the what is AWS and what are the logics we will be using to process this SCADA the data, and what are the protocols we will be using to communicate from the on-premises to the cloud, right? And so, and also we have the concept called IoT in the AWS. So how the IoT will be, uh, we are using that service to predict what will happen in the future, correct? And also we have the forecasting to see the dashboard, what exactly the service what we will be using in the AWS. So this is what we will learn in the next class. So I will just pause here for today's session, and so I will be continuing tomorrow on the edge computing. So I will talk about the cloud architecture tomorrow and the golden rules and the IoT platforms, right? Yeah. So I will stop here. Anybody has any questions as of now? No questions? Okay. For tomorrow's class, I want everyone to go through the AWS documents. Okay. AWS IoT documents. So are everybody okay with that? I want response from everyone. Hello.
Yes, sir.
Okay. I just want to have the feedback. Okay. So anything improvement you feel like it has to be done from my end, or else any materials you would need. So what it is like, I want the feedback from everyone so that we can able to improve the connection between me and you, right? And also you should get the most out of the latest technologies, and you should be able to do your assignments. So whatever the topics what I am covering, it will be induced in the assignments. Okay. So please make sure that you go through the recordings or go through the materials, and also you guys has to do the some research on the specific topics. And if you feel like there needs to be more detailed way of presentation, or more documentation is needed, please let me know. I can able to provide. Okay.
Sure, sir.
Okay, sir.
Okay. So tomorrow's class, please go through the AWS documents. We'll talk about IoT. We'll talk about the processing of the data in the AWS, and also we will talk about how we are going to connect the on-premises SCADA system to the cloud, and then we will use the Gen AI, the models, the basic level, and we will go in the depth in the second, I think, fourth class. Okay. Yeah. So thanks for joining, and have a nice day. Okay. Bye bye.
Thank you, sir.